Okay, so good morning. I'm here on behalf of my head of department, Dr. Chakrabarti. Just to give a little review of what is going on in the chemical engineering department at UWE. The Department of Chemical Engineering is doing research in areas to develop a more sustainable industrial sector and country. As far back as 2013, we had an MSc project entitled Feasibility of Hydrogen Generation from Renewable Energy Sources in Trinidad. This is well before the term hydrogen became sexy and it was on everybody's front burner. Okay, current research includes optimization of sustainable energy transitions, looking at electrolytic hydrogen as a feedstock instead of getting the hydrogen from natural gas, ultimately reducing the life cycle greenhouse gases. Okay, sustainable development of petrochemical industries, ammonia and methanol in particular, finding ways to reduce emissions, including replacement of hydrogen from the steam reforming of natural gas, and with the accompanying emissions of CO2 with hydrogen produced from electrolysis via renewable energy resources. We're also looking at developing of more industrial symbiotic linkages among companies in the Point Lisas industrial estate, looking towards its development as an eco-industrial park. We're looking at using waste to develop useful products, potentially leading towards a circular economy. Among some of the works that we've done is conversion of seaweed, this I got some seaweed, into bioplastics. And we're looking at ion exchange compounds. And we're looking at producing activated carbon from bioresources with applications for carbon capture. Okay, as well as life cycle analysis of many industrial processes and using renewable energy sources to reduce greenhouse gas emissions. We've also done some implementation of changes in our curriculum as far as our final year design project is concerned, where we add sustainability and looking at green production methods. So this morning presentation will be based on a final year research project on the life cycle analysis of green ammonia production by Ms. Daniuska Mago. Daniuska graduated from our department with a BSc Honors in Chemical Engineering in 2023. I'll pass you on to Daniuska.
Thank you, Dr. Smith, for that introduction. Welcome, ladies and gentlemen. I am Daniuska Mago, and I will be presenting the environmental impact analysis on a green ammonia process. Just bear with me a bit so I could, right. So today I would be speaking about what is green ammonia, the importance of a LC analysis, what is the procedure to conduct a LC analysis, the key environmental impacts, and the pros and cons of green ammonia. So green ammonia can become a climate neutral transportation fuel in the future. This uses renewable energy such as solar, wind, or hydroelectric power. The raw materials would be hydrogen and nitrogen from the air. And green ammonia is important primarily because it is used as a source of energy for hydrogen. It is carbon neutrality. It serves as a transportation fuel, and it can potentially decarbonize the food industry. To give a little brief introduction to the process, the plant uses solar energy, and the two main inputs are salt water and air. Firstly, the salt water is desalinated, and the components are then sent to the electrolysis where the hydrogen and oxygen molecules are split. Then the hydrogen gas is then mixed with the nitrogen through pressure swing absorption, and then they are sent to a reactor where the Haber batch process occurs. The outlet gas then is cooled and separated to obtain the green ammonia. The life cycle analysis is important as you can identify areas for improvement, ensures regulatory compliances, and it promotes sustainability initiatives across the various industries and sectors. The life cycle stages for this process would be solar energy, electrolysis, nitrogen production, ammonia synthesis, purification, and storage and end users. In order to conduct an LC analysis, you need to undergo these five variant steps. The first one being the goal and the scope, second one, the life cycle inventory, third, impact assessment, fourth, interpretation, and fifth, the improvements. Now, the goal and scope of this process, the objective is to identify the main inputs and outputs and the system boundaries and see how their chemical components affect the environment. The production is based on 1 metric ton of ammonia per hour, and an alkaline electrolysis is used. For step two, the life cycle inventory, the objective is to see the potential environmental impacts associated with the production, considering various impact stages. In order to obtain these life cycle inventories, programs such as Aspen ISIS and SIMAPRO was used. For our third step, the impact assessment, this is used to quantify the potential environmental impacts of the process and see how it affects the various impact categories, the main ones being global warming, abiotic depletion, and ozone layer depletion. After the results and the findings were generated, it was seen that even though green ammonia can reduce carbon emissions, the conventional ammonia process is preferred, and this is due to the upstream effects. Now, from the picture seen below, it is seen that the green ammonia process has a very high impact on the environment. This means that the solar panels are made out of fossil fuels, which have a negative impact on the human health and ecosystems. A next major impact of green ammonia is water consumption. It has the ability to cause eutrophication and plant overgrowth in water bodies. Now, as we relate to the social and economic impact, for our main input streams, which is water and air, you would have a total expenditure of approximately 3,500 US per year, and it can produce a total product profit of approximately 15.4 million USDs per year. So, green ammonia has its advantages, such as low carbon production and energy storage, but it also has its disadvantages, which would be infrastructural development and supply chain complexity. When it comes to green ammonia, conventional ammonia would obviously, I mean, when it green ammonia would obviously have more benefits than the conventional ammonia, the main ones being land use, reduced greenhouse gases, and air quality. So, if you want to know if green ammonia processes actually do work, I took a little example, and in according to the Ammonia Energy Association, they actually use in America, North America, they actually supply wind and solar energy to their electrolysis, and this accounts for more than between 2030 and 2050, they could have a 90% reduction in emissions, which is very amazing. Now, certain challenges that we can phase with this green ammonia process would be efficiency of electrolysis, integration of renewable energy, and carbon capture and utilization. But there are ways in order that we could improve. So we would have to improve in LCA advancements, optimization, and environmental and safety factors. In order to do this, we have to do further research in these fields and learn how to improve our cutting edge technologies. So, in conclusion, this green ammonia process doesn't agree with literature, and this is just due to the upstream products that were used and the data that was used and inputted in the simulations that were ran. So, therefore, the conventional ammonia process would be preferred, but further research on those critical points have to be done. And in order to comprehend the full advantages and disadvantages of green ammonia and how it would be used as an energy carrier, I would like to thank the Department of Chemical Engineering, my lecturers, and my family members that are here. Thank you all for giving me this opportunity, and this concludes my presentation.